say 38. Caught my eye this time. You want to choose? You're getting ready to choose?
No, 38 is good.
A sub n, a n, the general term or the nth term, 1 over n plus 1 minus 1 over n plus 2. So here they're asking us to find S1, S2, S3, S4, dot, 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 and also Sn. The first 4 partial sums and the last one. Okay? So, S1 means n is 1. 1/2 minus 1/3. Since I need to find it, 3 minus 2, 1/6. S2 is S1 plus the next term, right? Plus A2. So I already have it, 1/6. Plus, now when n is 2, 1/3 minus 1/4. I just realized that if I hadn't used the sum S1, I would have been able to simplify, and I'm going to do that. So instead of 1 over 6, I'm going to write 1 over 2 minus 1 over 3 plus 1 over 3 minus 1 over 4 because it's easier. And 1/2 minus 1/4 is 1/4. So I determined S1 and I determined S2. Now I'm on S3. S3 is 1/2 minus 1/3. Say it again.
It's not 1/4.
It should be 1/6 plus 1/4, but I want to start from the beginning because terms will cancel out. But you're right. It will be 1/6 plus 1/4, and plus the next.
Okay.
It will. I'm sorry. Forgive me. It will be 1/4 plus the next.
Okay. Yes. Let's do that.
Yes. Yes. So this is. I'm writing A1. This is A1. Plus I'm writing A2, which is 1/3 minus 1/4 plus A3. Right? So S3 is A1 plus A2 plus A3. Good. So A3 will be 1/4 minus 1/5. And here's what I do next. So what I have is 1/2 minus 1/5, which is 3 over 10. With S4, I'm going to do the same thing. I'm going to copy A1, I'm going to copy A2, I'm going to copy A3, and I'm going to add A4. 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 plus 1/5 minus 1/6. A1, A2, A3, A4. The sum of the first 4 terms of the sequence. So this is 1/2 minus 1/6, which is 3 minus 1, 2 over 6, or 1/3. So I determined the first 4 partial sums. The first partial sum is just the first term, A1. The second one is A1 plus A2. The third one is A1 plus A2 plus A3. And this was the last one, A1 plus A2 plus A3 plus A4. This is extremely useful to notice because now I want to get to Sn. Yes. So I have 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5 plus 1/5 minus 1/6 plus dot 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 plus. I want to write the last 3 terms. I want to write an minus 2 plus an minus 1 plus an. So S sub n or Sn is the nth partial sum, which means, thank you, which means I have to add the first term, the second term, the third, the fourth, the fifth, the n plus second, plus the n plus first, minus first, plus the nth. N minus second, n minus first, up until including the nth, correct? Perfect. So now, using the formula, I plug in n minus 2. N minus 2 plus 1 is n minus 2. N minus 2 plus 1 is 1 over n minus 2 plus 1. N minus 1 minus n minus 2 plus 2. Thank you. Plus n minus 1 now. N minus 1 plus 1 minus n minus 1 plus 2. Very good. Last one with n. It has to be this. This is an, right? So 1 over n plus 1 minus 1 over n plus 2. Ready? Okay. Everything else went away. So then, I can still rearrange this in one more step. S sub n is n plus 2 minus 2 over twice n plus 2. I found the least common denominator to be twice n plus 2. I multiply the top by n plus 2 and the top by 2. So I have n over twice n plus 2. Any questions? Yes?
Yeah, which one of those fractions are the S1, 2, 3, and 4? So I'm just confused on why
Okay.
it's not the. I thought S2 was 1/6 plus 1/3 minus 1/4.
Which one? S what?
2.
So S2.
Or is this 2 where you're using the 1/2 minus?
So remember we have A1, comma A2, comma A3, comma A4, comma A5, comma dot dot dot.
Right.
S1 is only this.
S1 is only 1/2 minus 1/3.
Only A1. 1 and 1. 1/2 minus 1/3.
Right.
Which is this.
But instead of using 1/6, you use 1/2.
Because I wanted
So you can cancel.
because I wanted to cancel.
Right.
So S2 is the sum of these two. So it's S1 because it happens to be A1 plus A2. This is A2. 2 plus 1 is 3, 2 plus 2 is 4. So this is S1 because I already calculated it plus A2. So this is A1 plus A2.
Okay.
Instead, I went back and I said, okay, I'm not going to use 1/6, I'm going to use 1/2 minus 1/3 because this is 1/3 minus 1/4 and these two go away.
Okay.
So that's why I get S2, which is A1 plus A2 as being 1/4.
Okay.
Then for S3, I have to have A1 plus A2 plus A3. Instead of using S2 plus A3. All these 4 terms go away, and I have 1/2 minus 1/5. And you observe that this is basically the pattern. I just wanted to show you the last 3 terms, and this is all of them we ended up calculating them with the first and the last. The same thing for Sn, of course, first minus the last.
Okay. And then my second question is when it's when it has the A and then the subscript n minus 2. That's
I wanted to show you that this is,
the denominator. You only use the n minus 2 in the denominator.
no, n is n minus 2.
And is n minus 2.
Right.
Oh, okay.
So if you go back here, how do I determine A1? A1 is 1 and 1. How do I determine A5? It's 5 and 5. How do I determine A n minus second? N minus second, n minus second.
Okay.
Better?
Yeah.
I wanted to show the last three terms. Although we saw the pattern in the first determining S1 through S4, we already saw the pattern is the first minus the last. But I wanted to show you how to determine two more terms if you need to, or more than just two. So I wanted to show basically that this, although I can, it's going to be forever, right?
Right.
This will cancel with this will cancel with this, and this will cancel with this, and finally I only have the first and the last, like I did for all the other partial sums.
All right. Yeah, that makes sense.
Better?
Yeah.
Okay. That's pretty much it. I would like to look at the word problem now to see what's with these sequences. And okay, let's say compound interest. Yeah, why not? 72. To see the application, one application for sequences. Helen deposits $100 at the end of each month into an account that pays 6% interest per year. Compounded monthly. The amount of interest she has accumulated after the end month is given by I sub n. This is like Sn, right? 100 multiplied by 1.005 to the nth power minus 1, everything divided by 0.005 minus n. So this is given to us. Find the first 6 terms of the sequence. So in part A, they want us to find I1, I2, I3, I4, I5, I6. What do you recommend we do?
Oh, wait. No.
Why is it saying that?
Huh?
Oh, yeah, I clicked on something else. Okay. So let's go to the graphing calculator. And let's put in, I don't need the sequence now, so I have to go back to function. This is a function. This is not a sequence. So let's go back to function, y equals. Okay. So we have 100
So change from the mode to
in parentheses.
Oh,
Don't forget about parentheses again for the numerator. 1 point.
You're still on the paper.
1.005 to power x, caret x. And then minus 1. Close the parenthesis for the top. Divide now by 0.005. And then outside minus x. And we put in everything. Close the parenthesis. So they want us to find I1, I2, I3. So I go to second and table. And I plug in 1, 2, 3, 4, 5, and 6. Yes, and 6. Very good. So I1, I'm going to copy them. I2, 0.5, I3, 1.5025, I4, 3.01, I5, 5.0251, and the last one, 7.5502. Okay. Find the amount in the account after 3 years. Oh, now I'm sorry, I was reading from a different problem. Find the interest she has accumulated after 5 years. So N in this problem is in month. So in part B, they want us to find the interest she accumulated after 5 years. Equals 5 multiplied by 12, which is 60 months. Because in the formula, so we have N in months. So plug in 60, and you will see the interest accumulated, $977. So I-60 is 977. We didn't have to use the sequence because it was not a recursive relationship. But if it's given as a recursive relationship, like, for example, problem 75, it's a different story. So let's look at 75 on page 794. Fish farming. A fish farmer has 5,000 catfish in his pond. The number of catfish increases by 8% per month, and the farmer harvests 300 catfish per month. Show that the catfish population after n months is given recursively by, so we are given P0 is 5,000, and Pn, P sub n, equals 1.08 times P sub n minus 1 minus 300. This is a recursive, this is a recursive relationship because the nth term depends on the term before it. So now I have to use that u of n, 1.08 times u of n minus 1 and minus 300, in which the minimum is 5,000. So now I have to go to mode and change it back to sequence. Okay, so n is given in months, and the second part of the question after we copy this, how many fish are in the pond after 12 months? That will be part B. So let's go to mode, go to sequence again, and then go to y equals, clear. Okay, u sub n is 1.08 multiplied by second and u, it's 7, in parentheses n minus 1, close the parenthesis, and minus 300. Okay, so n minimum I think it's 0 for this. And u of n minimum is 5,000. Let me know if this is okay. And then it says, just show that the catfish population after n months is given recursively by this. Which is, it makes sense because the increase is at 8%, and every month. So whatever amount we had before increased by, and we will plug in some numbers in a minute, increased by 8%, and then he removes 300 from them. Okay.
So what are we trying to do?
We're trying to check. We're trying to check few values. So he starts, one more time, he starts with 5,000. It says a fish farmer has 5,000 catfish. So the first month, 500. Now let's think. That number increases by 8%, and then we remove 300.
Yeah.
So 5,000, where's my calculator? 5,000 multiplied by 1.08 and then minus 300 for at the second, when I punch in 2, I have to get, yes. So when I punch in 2, so he starts with this, and at the end of the first month is 5,100. Okay. Then at the end of the second month, so it's 5,100 now, 5,100 multiplied by 1.08. So whatever he had at the end of the first month, 5,100, and then subtract 300, and that's 5,208. So yes, at the end of the second month is 5,208. So we checked that it appears that the recursive formula is correct. Now, final question, part B. How many fish are in the pond after 12 months?
6,897.
So I have to plug in 12, and I get 6,898 because I can have 0.7 of a fish. When it comes to people, fish, mice, I would not round up. I would say 6,897. Yeah. Okay, good. Final thing that we have to look at, geometric sequences. This is the last section, 12.3. Geometric sequences. The geometric sequence is a very special type of sequence. The terms have a special property. The first one is a number, any number you want, basically. Anything you can think of. But the next term, so this is the first term of the sequence, first term. It can be anything. But the second term, for this to be geometric, the second term is obtained multiplying the first term by a number. And that number is denoted by R, and it's the ratio of the geometric sequence. So the next term, can anyone give us the next term? If it's obtained multiplying the first one by R, AR, comma. Can anyone give us the next term? That's it. And the next term. Notice something very important to remember. The first term doesn't have R. The second term does. At power 1. The second term, power 1 for R. The third term, power 2 for R. Now I'm going to ask you for the general term.
So the first term's like A times R to the 0.
Yes.
Because it would be 1.
Yes. So I want the nth term or the general term now. Exactly. That's all I want you to say. So please remember, A sub n, for the geometric sequence is A multiplied by R to n minus first, or n minus 1. That's the general term of a geometric sequence. R is the ratio. How do I determine the ratio? Or we'll have plenty of examples. How do I determine the ratio? Dividing this by this. Dividing this by this. I'll get the ratio. So let's look at a few examples and then come back to how to find the sum of a finite and sum of an infinite geometric sequence. Okay. The nth term of a sequence is given. Find the first 5 terms of the sequence. And what is the common ratio? Ratio or common ratio? Let me put common ratio. But that's what it means. Okay, 5 through 8. Let's say 7. In 7 we have a sub n equals 5 halves, and in parentheses, negative 1/2 raised to n minus 1. the nth term of a sequence is given. Find the first 5 terms. And what is the common ratio? And we can also graph. When we graph a sequence like this, we can identify whether it's increasing or decreasing. Okay, so when you compare to a times r to n minus 1, you will immediately, because I may ask you this, find a. How much? That's it. Find the common ratio, or the ratio. -1/2. So now they want us to find the first 5 terms. So let's find the first 5 terms. We don't have to find 5, let's find 3. A1 equals 5/2 times -1/2 to 1 minus 1, which is 0. So this is 5/2. What will A2 be? You can go back and plug it in, or you can multiply 5/2 by -1/2, right? Because the second term is A, which I know is 5/2, right? Times the ratio, the common ratio. That's what I wanted to show. Or you can go back and plug it in. You can plug in 2, right? So it's the same thing, 5/2 multiplied by -1/2. If you plug in 2, 2 minus 1 is 1. When you multiply these two, you get -5/4. Right? This multiplied by the ratio. Now what about A3? Is the previous one, which is A2, multiplied by the common ratio. Very good. So -5/2 times -1/2 will be 5/8. Okay, let's do one more. A4. How do I get A4? It's right here. A4 is this multiplied by the common ratio. So that would be -5 divided by 16. Okay, let's graph this. So let's go to y equals, but I have to establish whether this is a function or recursive relationship. If it's a recursive relationship, I have to stay in sequence, and if it's just a function, I have to go back to function. And the answer is, I have to go back to function. So let's go back to function. So let's go to y equals, clear. So I have 5/2, or 2.5, and in parentheses, -0.5, in parentheses, caret, or power, in parentheses, x minus 1. So now I go to second table. So when a is 1, I see 2.5. When a is 2, 1.25, right? Because we got -5/4. For a equals 3, we got 5/8, which is 0.625, and so on and so forth. As you see, the terms of the sequence are alternating. Okay, so now, what do we want to see? First of all, x, we have between 0 and 6, because the viewing window is crucial here. Okay, so x values are between 1 and 6. That's what we plugged in. Okay, how low do I go for y? Well, I don't know. -1.25 is the lowest. So I'm going to say in the window, 0 to 6 for x, scale of 1 is okay. But for y minimum, just -2, and y maximum +2, and just click on graph. And here they are.
26.
Let me change the viewing window a little bit. So we had, yes, because we had 2.5, that's why. So I have to go to 3 for y maximum. So here it is. 1, 2, 3, 4, 5, 6. 5, 6.
Okay. Sorry to see on this.
So it's a decreasing sequence. On the positive side is decreasing, and on the negative side is approaching 0. Okay. So we graphed it. Find the nth term of the geometric sequence with given first term A and common ratio. So let's say problem 12. We are given A, which is the square root of 3. And we are given R, which is the square root of 3. Fine. Find the nth term of the geometric sequence. And find the fourth term. So A sub n, or an, the nth term is A multiplied by R raised to n minus 1. And we know why it's n minus 1, correct? Did you graph it? Joey, are you okay?
Yeah, it's not all the dots are shown.
But because you have to go to 3. Because the first one at the top is 2.5.
Yeah, even that one didn't show up. I'm not sure.
Oh, really?
I mean, it's in the table, but
Same. I got the same. Yeah, not all
I don't know if
my
it's just because my calculator is old or what.
No. Why would it?
So it's on the table. 1, 2, 5.
Right, so let's look at the
I
viewing
have it
window.
at 3.
One
Okay, that's
maximum
easy.
-2, right, okay, and when you graph,
There's not the one.
Dot. You don't see the 1, 7, 1.
or at 2.5, because
Right.
this is 3.
Oh, it would be like right here. So I just think it's a little.
To be honest.
Weird.
You're
Did you
getting
see?
one.
I only have 4 hands.
Yeah.
Oh, this is very close.
But it's on the table.
Very, very close.
Yeah, it's on the
Okay.
table.
And this one is very, very close.
I see. Steven only got 1.
Yeah, those are very, very close to the to 0.
Okay.
Right, because you see, it's negative 0.0781.
Right.
That's why it's almost on the x-axis.
That makes sense.
Okay, so we want to determine the nth term. So this is the square root of 3 times the square root of 3 raised to n minus 1. So it happens that the general term for this is, copy the base, add the exponents, n minus 1 plus 1, the square root of 3 raised to the nth.
So that's the nth term.
The nth term of this geometric sequence, correct, yes. Now if I want to determine A4, copy the base, add the exponents, n minus 1 plus 1 is n. So A4 will be the square root of 3 to the 4th power, which is 9. Paul, is this okay?
Why?
I'm sorry?
On A to the N, why is it?
You're looking at this?
Yeah.
So this is A, it's given to us, so I replaced it. This is the common ratio, it's given to us, I replaced it. I have to raise it to n minus 1. These two are identical quantities that I multiply. Two identical quantities are multiplied, I copy the base and add the exponents, and I get n.
Oh, okay.
Oh, because really there's a 1 there.
Yes, of course.
Ah.
Of course, yes. Is that okay?
Yeah.
Good. So let's continue with determine whether the sequence is geometric. So let's say problem 16. 27, comma, negative 9, comma, 3, comma, negative 1, comma, dot, dot, dot. So we are asked whether this is a geometric sequence. It doesn't have to be, but is it? Remember, if it is a geometric sequence, this is A, comma, the next one is times the common ratio, a times r squared, a times r cubed, dot, 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 which means when I divide this by this, I have to get one number that I get when I divide this by this, a same number when I divide this by this. Because in order to find this, I multiply by r. To find this, I multiply this by r. To find this, I multiply this by r. So if any two consecutive terms, if I divide them from right to left, of course, if I get the same number in all cases, then I'll say it's geometric. So -1/3 is this over this. 3/-9 is -1/3. And -9/27 is -1/3. So it appears that this is a geometric sequence, and the common ratio r is -1/3. And what is r? I'm sorry, what is a in this problem? Is the number that I multiply by -1/3 to get this. What number I multiply by -1/3 to get this?
27.
So 27 multiplied by -1/3 is -9. So a equals 27. Which makes sense. Okay, let's also look at, I don't know, 17. In 17 we have 1/2, 1/3, 1/4, 1/5. 1/2, 1/3, 1/4, 1/5, dot, dot, dot. The question here is the same. Is this a geometric sequence? When I divide 1/5 by 1/4, I get 4/5. But when I divide 1/4 by 1/3, I get 3/4. Are they the same? No. Not geometric. Not geometric. Okay, 21 through 26. Find the first 5 terms of the sequence and determine whether it is geometric. If it is geometric, find the common ratio and express the nth term of the sequence in the standard form. Okay, please choose. 21 through 26. Whatever you want. 24. So in 24 we have a sub n, or the nth term, -1 to the nth power times 2 to the nth. And find the first 5 terms of the sequence. Okay, not a problem. A1, A2, A3, A4, A5. You can put it in if you want as a function and punch in 1, 2, 3, 4, 5. So when I punch in 1, I get -2. When I punch in 2, I get 4. When I punch in 3, I get -8. When I punch in 4, I get 16. And then for 5, -32. So we found the first 5 terms of the sequence. Awesome. Is this determined whether it is geometric? Is it geometric? I don't know. When I divide -32 by 16, I get. When I divide 16 by -8, I get. When I divide -8 by 4, and when I divide 4 by -2, what do we conclude? Geometric. Good. Then we're asked to find the common ratio, which we did. Express the nth term of the sequence in the standard form a sub n, that's the last thing, equals a times r to n minus 1. So all I have to do is identify a. Once you give me a, r is very clear, is -2 to n minus 1. There is no question there. We determined the common ratio. So I replaced r by -2 and its power n minus 1. And now let's figure out what goes in front. if I put 1, remember, a is what I multiply first by -2 to get this. So this has to be a. Right? So if I put a 1, then for n equals 1, n equals 1, 1 minus 1 is 0, -2 to 0 is 1. Right? So now let's try this. For n equals 1, 1 minus 1 is 0, so this is 0, so I get -2. For n equals 2, 2 minus 1 is 1, -2 times -2 is +4. When n equals 3, 3 minus 1 is 2, -2 squared is 4, 4 times -2 is -8. Okay? And so on and so forth. Clear? Perfect. Okay, determine the common ratio, the 5th term, and the nth term of the geometric sequence. So now we are told these are geometric. Okay. 34 caught my eye. Unless you want to choose something else. In 34 we have t, comma, t squared over 2, comma, t cubed over 4, comma, t to the 4th over 8, dot, dot, dot. Determine the common ratio, the 5th term and the nth term of the sequence. Okay, so when I divide this by this, let's see what happens. T to the 4th over 8 times 4 over t to the 3rd. This goes away with this, and this. So I have t over 2. So it appears that the common ratio is t over 2. I still have to check just to make sure, although I'm told they are geometric, so there is no discussion here. Just making sure. T to the 3rd over 4 times 2 over t squared. I simplify, and yes, I get t over 2 again. Okay, so a sub n is a multiplied by r raised to n minus 1. So we know this is geometric. One more time, they are asked us to present the nth term and then find the 5th term. So a sub n has the first, so it has a, and it has t over 2 raised to n minus 1. And now the question is, what is a? Yes. I have to try to simplify it as much as possible and then find the 5th term. So this is t multiplied by t to n minus 1 divided by 2 raised to n minus 1. The numerator becomes, copy the base at the exponents, copy the base, very good, divided by 2 to n minus 1. And now I can find a5. T to the 5th divided by 5 minus 1 is 4, 2 to the 4th power, or I can write it as t to the 5th divided by 16. Any questions? Any questions? I need more paper. Okay. So let's go back to partial sums. But now for a geometric sequence. This is the last thing we need to do. Okay. So a plus ar plus AR squared plus AR to the third plus dot 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 plus AR to the nth minus 1, A1, A2, A3, A4, AN will be denoted or will equal to what? How do you think we denote this? If you go back to your notes from half an hour ago, you'll say, oh, I know, this is sub. That's it. Exactly. It's the sum, it's the nth partial sum, because I added the first n terms of a geometric sequence this time. Okay. Can you please multiply everything by r? Actually, by negative r. So look at the first equation. The top equation is S sub n equals blah, 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 blah. And now I would like you to multiply all those terms, the left-hand side and the right-hand side, by negative r. What will be the first term I have to write? I'm not going to write it under this. I'm going to write it under this. Then the next one. And then the next one. Minus dot 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 minus AR to n minus 1, because the previous one will have r to n minus 2. It will create this. But there is one more now, because I have to multiply by this. So minus AR to the nth power. Agreed? So when I multiply the first one, I get this. When I multiply the next one, I get this. The next one, I get this. The next one, I get this. This one, I get this. And when I multiply this one by negative r, I get this. Copy the base, add the exponents, correct? Is this okay? Okay. So then, now I'm adding these. So the left-hand side is S sub n minus r times S sub n. And now what is left? Gone, 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 gone. So it's a minus a times r to the nth power. What am I after? Look at all this and say, I know what you're after. You're after blah, blah, blah of a finite. Why it's finite? Because I don't have plus dot, 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 right? This is not infinite. The finite sequence is called the sequence, and the infinite sequence is called a series. So, what am I after? Look at the title. Right. So what will I do next? Remember the 3 key words. I added one more in the meantime. Clean it up, or concepts. Clean it up, factor, and simplify. These have to be in the back of your mind forever when you do math. So what do you think I am going to do now? Knowing that I am after this. Not divide, but I want to solve for S sub n, and I cannot combine them. So then if I want to solve for S sub n and I cannot combine them, then the only option is which of the 3? Absolutely. So I have to factor out S sub n. What is left? Very good. Here I will also factor a, 1 minus r to the nth power. So then the nth partial sum of a geometric sequence only is a, in parentheses, 1 minus r to the nth power over 1 minus r. This is the nth partial sum of a geometric sequence only. Now we can answer a couple of questions. Find the sum. So I would like to look at, let's say 47, in which we have 1 plus 3 plus 9 plus ... plus 2187. I see that this is a finite partial sum, right? It ends at 2187. I have to identify whether this is a geometric sequence. If it is a geometric sequence, I have to identify A and R and plug them in, and I have to identify what this N is. Right? So, because I don't know, what is this 2187? I have no idea. Okay. So, first of all, is it a geometric sequence? When I multiply this by a number, I get that. When I multiply this by the same number, I get this, and so on and so forth. So it appears that the common ratio is 3. So then I have the 3 and the 3. I'm missing the 9. I'm sorry. I'm missing the A and I'm missing the N. Right? So right now, I know that this is S sub something, which I don't have yet. I don't have the A, not to be understood that it's the same number. And I have 1 minus 3. Again, I don't have the N, over 1 minus 3.
So,
Yes.
is it 1?
Yes. A is 1. Good. But now I have to identify this. So 2187 is the general term, and this should be A multiplied by R raised to N minus 1. Is this okay so far? So this is 1. So now the question is 2187 equals 3 to a number N minus 1. What type of equation is this? Because we've seen it. Aha! How do I solve it? I can change this into 3 to some power, but it will take some time. Or I can say I don't need that. I have another option. Very good. Either one. So there I have natural log of 2187 equals N minus 1 natural log 3. What am I looking for? What am I after? What am I determining? Of course. So what do I do then? Absolutely. And then add 1. Very good. Awesome. So then N minus 1 equals natural log of 2187 over natural log 3. And then N equals 1 plus whatever this is. Okay, I grab my calculator and I have 1 plus natural log of 2187 divided by natural log 3. And I got 8. So N is 8. So I have everything. 8 and 8. So now I can determine the sum of those numbers. So it's S sub 8, which is 1 minus 3 to the 8th power over 2. Something is wrong. Yes, I was just looking at. It cannot be a negative number. Yes, because I wrote positive 2 instead of negative 2 in the denominator. Sorry. So it's 1 minus 3, which is not 2, but negative 2. 1 minus 3. Sorry about that. Okay, so then we have 1 minus 3 raised to the 8th power. And divide this by -2, of course. 3280. 3280. So this was possible because we knew how to find the nth partial sum of a finite geometric sequence. And because it was geometric. Okay.
The top here down just a little bit.
Yes. Find the partial sum Sn of the geometric sequence that satisfies the given conditions. So 45 caught my eye.
So I have a question.
Yes, please. Yes.
S 8. Okay. So can you just move the paper down a little bit? Okay, so before we didn't know that it was 8 there.
We did not.
So you would read the S sub n?
It's S sub n and we don't have the n. Yes. Yes. Correct. Yes, you can write here S sub n as being a 1 minus r to the nth over 1 minus r. Is that better? Okay, so I think I said 45 on page 806. A3 is 28. A6 is 224. And n equals 6. It says find the partial sum Sn, which means S6 we are asked to find, of the geometric sequence that satisfies the given conditions. And then I have one more item to say, and that's it. Okay. So I know that the general term, or the nth term for a geometric sequence is a multiplied by r to n minus 1. So please tell me, how will you write A3? A3 will be a multiplied by the common ratio squared. And this is given to us as being 28. This is our first equation, because I have two variables. So this was information that was hidden in A3. Now please give me the information hidden in A6. You will say A, you will say r to the, very good, and then you will equate this to 224. And this is the second equation that we need. We have a system now with two equations in two variables. One variable is a, and the other variable is r. So here's what I would recommend do. We can divide them. This divided by this is 1 over r cubed. This divided by this is 28 over 224. That's one option. You can say, how did you come up with this? You can multiply and divide equations. Another option would be to solve this one for a. So this is 28 over r squared, and then plug it in here. And you'll get the same thing. So a is 28 over r squared times r to the 5th equals 224. And you'll get the same thing because you will simplify. You get r to the 3rd. So I got r to the 3rd times 28 equals 224, which is the same thing. So, or this one, same thing. R cubed equals 224 over 28 from either one. Obviously, what type of equation is this? And I know I will have to apply what to both sides? The cube root is the inverse operation, right? So then r equals the cube root of 228. Don't forget, these are radical equations. This is a radical equation. So the cube root I don't like the cube, but I always put power 1/3, but that's me. So 224 divided by 28, and I take it to power 1 divided by 3. And I got 2. How nice. So I determined the common ratio. And once I have the common ratio, I can go back here and determine A. So 28 divided by 4 will give us A to be
2.
So 28 divided by 4, A is, so the common ratio 7. Good. So now we know A sub n, the nth term of the sequence, which is 7 multiplied by 2 raised to n minus 1. Therefore, A6 is a, I'm sorry, I don't want A6. I want S6, sorry about that. Therefore, S6 is a piece of cake, right? Knowing the formula, which is A multiplied by 1 minus r to the 6th power over 1 minus r. So A, 1 minus r to the 6th power over 1 minus r. So then A is 7, 1 minus 2 to the 6th power over 1 minus 2. So this is the 6th partial sum. Punch it in the calculator. 7 parentheses 1 minus 2 raised to the 6th power, and divide by negative 1. And I got 441. Let me know what you get.
I have a question.
Yes,
Can you go back to how you got R equals 2?
the cube root of this. So this over this, everything in parentheses to power 1/3.
Yeah, how did you get there?
Cross multiply. So r to the 3rd times 28 equals this, and then I divide it by 28. Or from here, 28 times r cubed equals 224.
Somehow I messed up. I substituted the A.
Yes.
and
So it's clear how we got a from the first one, right?
Right.
Okay. So then when I plug it in here, I have 28 over r squared. I simplify, and I get r cubed.
So yeah, 28 R.
28 r cubed equals this. I have to divide by 28. And then I have to take the cube root from both sides. Because I have r cubed equals 224 over 28.
Mm.
Is this okay?
There's negative 441.
Impossible. The denominator is negative 1. The numerator is negative. The denominator is negative.
Yeah, I didn't have the other
yeah.
side. That's what it was.
441. Paul, is this okay now?
Yep.
Perfect. Last thing for us. Ready? Let's look at this. A plus a times r plus a times r squared plus dot 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 plus a times r to n minus 1 plus dot dot dot. This is not a finite sequence anymore. It is geometric, so it's an infinite geometric series. We are interested here to determine the sum. Of an infinite geometric series. That's the last thing. Okay. So let's look at S sub n from a for a finite geometric sequence. Okay, so that is A multiplied by 1 minus r to the nth power divided by 1 minus r. Obviously, in this relationship, but this is not the infinite geometric series. This is this partial sum, right? The nth partial sum for a finite geometric sequence. Now, because of these dot, 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 what do you think happens here? N goes to, awesome, stay with me. So now the question is, what will this approach when n goes to infinity, right? So if r is 5, you're right. If r is 5, 1 minus 5 to infinity is huge negative. The bottom is negative. The sum will be positive. I don't care about this number. It will blow up. And I cannot find the sequence, the sum of the infinite geometric series. Infinity is not a number. So if r in absolute value is greater than or equal to 1, we say that the infinite geometric series, I cannot determine its sum. Instead, we say is divergent. Can determine sum. Therefore, it's divergent. But now let's think in for a different situation, right? What if the absolute value of r is less than 1? So now imagine 1/2 here, or 1/3, or 1/5. 1/2. 1 to the infinity. It's not 1, but let's say it's 1. But 2 to infinity is infinity. But 1/infinity is 0. So then, if that's the case, then this whole thing, so this will approach 0 in this situation, and the sum of an infinite geometric series is a over 1 minus r. But only if the common ratio is strictly less than 1 in absolute value. It can be anywhere between -1 and 1. So now I'd like to apply this, and this is the last thing. On same page 806, let's choose between 51 through 62. Okay, let's say 56. 1/3 to the 6th power plus 1/3 to the 8th plus 1/3 to the 10th plus 1/3 to the 12th plus dot, 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 and it goes on forever. Determine whether the infinite geometric series is convergent or divergent. If it is convergent, so this means convergent, I can find its sum. If the common ratio is a number between -1 and 1, then the geometric series sum can be determined. We say that the geometric series is convergent. Okay, finally. So we're asked to find whether it's convergent or divergent. In other words, if I can find its sum, it's convergent. If I cannot find its sum, it's not convergent. So what do I have to determine? So remember, the sum S sub n for a infinite geometric series is a over 1 minus r, and the common ratio must be less than 1. If the common ratio is 1 or more in absolute value, I'll say it's divergent. I cannot find its sum. This is it. So first I have to find the common ratio. I have to find A, and I have to find, the common ratio. Can anyone give us the common ratio? The common ratio is what I multiply this to get this. And at the same time, what I multiply this to get this.
1/3 squared.
Very good. Is 1/9 in absolute value less than 1?
Yes.
Yes. So what will you say automatically about this infinite geometric series?
It's convergent.
It's convergent. I will be able to find a sum. Good. Therefore, please identify A.
One.
So this is A. This is A times R. This is A times R squared. This is R, A times R
It always
cubed.
starts with A, right? If it's a geometric.
Yes. Sometimes it depends. We may have to factor out something.
So 1/3 to the 6th.
1/3 to the 6th. So 1/3 to the 6th divided by 1 minus 1/9. So 1/3 to the 6th divided by 8/9. 1/3 to the 6th times 9/8. So I will get 3 to the 4th, because this is 3 squared and this is 3 to the 6th. So the answer will be 1/8 divided by 3 to the 4th. 0.00154. Let's look at another problem. Last one. Say it again.
I'm saying you simplify it to what? 1/3
This is 3 squared and this is 3 to the 6th. So I have 3 to the 4th.
times 8.
Yes. Okay, let's look at 55. Same page. 1 plus 3/2 plus 3/2 squared plus 3/2 cubed plus ... How much is A?
1.
How much is the common ratio? What do we conclude? Is the infinite geometric series convergent or divergent? Divergent. Divergent because the common ratio is not in absolute value less than 1. Any questions? Any questions?